starts to feel kind of slow, as we can see here. Let me go ahead and open up. So almost every year I have to start searching for new visual demonstrations to use, because for a long time we use like those old school Java applets, which like barely even run, if at all, on Macs and PCs these days.
Them anymore.
No, you have to jump through hoops just to get a Java runtime to work. So this one's an HTML5 version, which is wonderful. And while it does show the algorithms from a different perspective using these tall bars for big numbers, small bars for little numbers, it's nice because I think this helps cut through the slower pace of our human demonstrations.
Yeah.
And you can actually see, in this case, things are bubbling up to the top much more quickly than our 8 volunteers could do. And we can have many more bars this way, too, so you can really see the aggregate effect.
Yeah, because sometimes even in those demonstrations, it's actually just people moving slowly. But here we have this sort of consistent time where one iteration is happening. And you can see that at the beginning, bubble sort takes a long time to move a single element. But as we begin to add more elements to the sorted portion at the end of the array, it's getting smaller and smaller. So we can students can sort of see this where things are inefficient and where things get more efficient, although overall, of course, bubble sort is not the most efficient of algorithms.
Yeah. Oh, and it's nice because now we can select another one like selection sort or insertion sort, even other algorithms that we ourselves don't tend to introduce in class can be visualized in this way. But by far, I think the most compelling thing to do, which we typically do after showing a few of these algorithms with this approach, is to compare those things side by side. And you actually see like selection sort and bubble sort and merge sort or any n log n algorithm competing against it. Like that's kind of a mind-blown kind of opportunity in
Somebody's
class.
got to get out there, though, and make it so that you can start running all of them at the same time, because you have to manually click on all the individual ones.
And they're always off, and then they're slightly different data sets, which is a little misleading that each of them is sorted a little differently. But on the whole, thankfully, it all kind of averages out.
Yeah.
But it is a powerful thing.
The other thing that's really cool to do is to show, there's a series of videos online where people have attached sounds to the various things. And if you're not a visual person, maybe if you're into music or into audio stuff, like maybe that's another
one
way
kind of
to show
hearing
it.
an algorithm, and getting a sense for its shape and its sound.
It's weird that they do kind of have shockingly different personalities almost associated with them.
They do. And then there's the, I think it's the Hungarian folk dances online that you can find on YouTube, where this amazing troupe of folks acts them out a little dramatically. I mean, they move around the stage even more than our humans do. But almost every year I get a text message or a message from some student in the class saying, hey, you should check this out. So that's cool that people engage with it and they start to see bubble sort or whatever all around. Like even the Barack Obama clip when he was being interviewed by Google's Eric Schmidt.
Yeah.
Like that's an amazing clip, even though it's in like super low quality SD on the internet. It's fun to hear someone like him actually say bubble sort. Right. Oh my God, it's relevant.
Here's that side-by-side that you were talking about.
Yeah, a little different. It rotates things 90 degrees.
It rotates things 90 degrees, and it's going to be painful when we start running on the first two.
My money's on merge sort. Who do you got?
I got merge sort too.
No.
All right,
you got to take another
I'll take selection sort.
All right, come on, merge sort. Come on, merge sort. Yes!
Do I have to buy you lunch now? Ugh.